Welcome back to RamZland. Today I want to show you a cool way to find out how much oxygen is really in the air we breathe. Check it out. All I'm using in this investigation is my Bunsen burner, 2 glass 100 milliliter syringes, and this little glass pipe that connects the 2 syringes, and inside is a little bit of powdered copper. The first step to demonstrate how much oxygen is really in the air we breathe is to use one of your glass syringes and to draw 100 milliliters of air from the classroom. The second step is to use a small spatula to add powdered copper to the glass tube connecting the 2 syringes. Finally, connect both syringes so they're nice and tight. Notice that one syringe has no air inside, and the other syringe has been drawn back to 100 milliliters of air from the classroom. Now you're ready to turn on your Bunsen burner and watch what happens to the copper inside the glass rod as we slowly push air from one syringe to the other syringe, back and forth slowly, about 15 to 20 times. You'll see the copper inside the glass tubing changes color during this reaction. Okay, once your Bunsen burner is on, you're gonna put it right underneath that powdered copper. And it's gonna start to oxidize the copper as the copper turns from brown to a darker black. Now, as this is heating up, I'm going to push one syringe so that it passes air over the copper. And I'm gonna do this back and forth. And what's gonna happen is that copper is gonna actually use up the oxygen that I'm passing over it in between that little glass pipe that connects both syringes. So I'm just gonna do this back and forth, and I'm gonna carefully heat both sides of that little glass pipe with the copper inside. And I can see it darkening. And after I do this about 15 to 20 times, I should see that there's less oxygen inside the syringe because some of that oxygen has combined with the copper to create copper oxide. So I keep moving this back and forth. And I can see that the copper is definitely changing color in the pipe as it turns from brown to black. Here's a closer look at how much air is now in the syringe. I'm going to push all the air from one syringe to the other. Let's find out how much air is in that syringe now. It was at 100. Let's find out how much is there now. And now look where the line is. Isn't that amazing? Some of that oxygen has bonded with the copper to make copper oxide. Here's a closer look at the copper oxide. See how it's really dark and black compared to the original color of the copper before I started heating it. Okay, so for some of our final results, I waited a few minutes for this to cool down because, you know, hot air expands and cold air contracts. And so I wanted to let the air inside this syringe to contract a little bit so I could really see the difference. We started with 100 milliliters of air, and now we're down to 80 milliliters of air in this syringe. And you can see this one's pushed in all the way. So if I subtract 100 minus 80, that means that about 20% of the air in this syringe was pure oxygen that's now bonded to the copper to make black copper oxide. So we've determined that at sea level, there's 20.9% oxygen in the air we breathe. And 70% of that is nitrogen, and some of it's carbon dioxide, and a very small amount of it's argon. But I filmed this in Indianapolis, Indiana, and we're 719 feet above sea level. And the higher you climb in altitude, the less oxygen is in the air we breathe. So let's take a look at the equation in this reaction between copper and oxygen. oxygen. This is a redox or reduction oxidation reaction where the copper, the Cu, is losing 2 electrons. It's the cation. And as it loses those electrons, it's being oxidized, and the oxygen is being reduced as it gains 2 electrons. It's the anion. And so as oxygen gains 2 electrons and copper loses 2 electrons, this creates an ionic bond of copper oxide. That's the CuO. That's the black product that you saw inside the glass tube between the 2 glass syringes. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.